Cell 1. In this code cell, we're laying the groundwork for creating a realistic employee engagement panel that spans an entire year. This is crucial for understanding how various factors, like departmental differences and employee roles, might influence overall engagement levels within an organization. To start, we import the necessary libraries, setting up Pandas options to display all rows and columns for better visibility. We use NumPy's random generator to ensure our results are reproducible, thanks to the setSeed value. The cell establishes parameters that define our employee population, including their number, the departments they belong to, their job levels, and their remote work modes. With 1,200 employees, the variety represented will help simulate a rich dataset. Next, we initialize a data frame that encapsulates the employee's static profiles. Each employee is assigned a unique ID and categorized into one of several departments, levels, and regions. The assignment is informed by weighted probabilities, ensuring realistic representations of distribution across these categories. For instance, certain departments are more heavily populated than others, which is often the case in real organizations. Then, we introduce specific metrics such as tenure, manager span, pay context relative to expected compensation, workload expectations, and meeting demands, all mapped according to department or level. This approach provides insight into not only compensation, but also the potential workload and meeting expectations employees might face. Additionally, we generate two latent traits: engagement propensity and burnout sensitivity. These traits are crucial as they introduce variability among employees that reflects their personal characteristics and resilience. By sampling these traits from a normal distribution, we can simulate some of the unpredictability that comes with actual employee behavior and engagement levels. Finally, we display the head of this data frame to give a glimpse of the generated structure. In the next cell, we'll likely begin to analyze how these employee profiles impact engagement metrics over the coming months, allowing us to dig deeper into relationships and trends. This setup is essential for creating a meaningful engagement analysis that can guide data-driven decisions. Cell 2. This cell constructs a comprehensive panel that captures employee data across different months, which is essential for understanding how various factors influence performance metrics. By merging employee information with a time component, we can delve into patterns and trends over months, offering insights into seasonality and other time-related behaviors. To begin, we set up a structured table by assigning a key to facilitate merging data on months with employee details. This allows us to generate a cohesive dataset that we can then sort sequentially by employee and month. With this basic structure in place, we move on to more intricate computations, such as assessing seasonal fluctuations through sinusoidal functions. This approach captures underlying patterns that might be too subtle to see directly. Next, we delve into remote work dynamics. We create a remote ratio that considers employee work modes: on-site, hybrid, and remote. This is further adjusted with some randomness to better reflect real-world variability, acknowledging that remote work could lead to different engagement and productivity levels. In terms of promotions, we establish probabilities that are influenced by tenure, employee levels, and engagement traits. This nuanced approach allows for the inclusion of complex behavior that influences promotions, with appropriate limits ensuring realism in outcomes. We also account for pay competitiveness, adjusting the pay comparison ratio based on both regional and departmental impacts, while sprinkling in some randomness for realism. Furthermore, we incorporate workload signals, computing overtime hours by looking at various contributing factors, from workload multipliers to seasonal patterns. Paid time off usage also receives attention. It increases with tenure, but decreases when workloads are high, reflecting realistic behaviors and including random vacation spikes to simulate unpredictable absences. The intensity of meetings and after-hours communication is also highlighted, factoring in employee-level and departmental affiliations to refine our estimates. We additionally assess collaboration volume through message and email counts, adjusting based on workload multipliers and department type to capture everyday communication dynamics. Finally, we examine response latency and work output, recognizing the negative effects of burnout and disengagement. This dual focus on latency and tasks closed not only reveals insights about productivity, but also highlights potential pressures faced by employees, particularly in different departments. As we wrap this cell, we set the stage for the next one, where we'll take this rich data set and analyze the relationships among these various factors to draw meaningful conclusions about employee performance and engagement. Cell 3. In this cell, we're diving deep into calculating various employee engagement and recognition metrics that are influenced by latent risk factors. This modeling is crucial because it captures not just current employee sentiments, but also the potential for disengagement over time. Initially, we establish a baseline for engagement using traits such as resilience and engagement scores, alongside other variables like pay comparisons and overtime hours. The output is a calculated engagement score, which we subsequently clip to ensure it falls within a valid range. Following that, an Employee Net Promoter Score, or ENPS, is derived, imbuing it with a bit of noise to make it more reflective of genuine variations. Next, we evaluate recognition events, which emphasize how often employees feel acknowledged for their contributions. This metric factors in elements like messaging intensity and departmental influences, ensuring we accurately capture the recognition landscape. Learning hours are similarly calculated, influenced by tenure and departmental affiliation, which shapes opportunities for professional development. As we progress, we introduce a latent risk score that might hint at quiet quitting. This score evolves over time and reflects trends such as falling engagement or increased response times. We define a risk drift for employees, accounting for gradual disengagement that may occur over several months. Moreover, we incorporate shock events, simulating organizational changes that could further impact engagement. Each employee is assessed for potential shocks around mid-year, adding a layer of complexity to the analysis. This informs how we recompute the engagement pulse, recognizing that as latent risk increases, scores will likely decline. Finally, we tweak observed behaviors to align with the latent risk scores. This ensures that as risk escalates, we witness a tangible reduction in communication volume and task closures, along with an increase in response latency, thus portraying a more comprehensive view of engagement. Looking ahead, the next cell will likely delve further into interpreting these calculated metrics and exploring how they can inform strategic decisions about employee engagement and organization health. Cell 4. In this cell, we're analyzing employee engagement through the lens of quiet quitting, a phenomenon where individuals disengage from their job without formally leaving. Our goal here is to assess the risk of quiet quitting by evaluating various factors that might indicate declining performance and collaboration. We begin by calculating a probability score for each employee that reflects their likelihood of quiet quitting. This is achieved through a sigmoid function, which transforms our inputs into a more interpretable probability between 0 and 1. Crucial inputs to this probability include the latent risk of quiet quitting, the number of tasks an employee has closed, and their engagement in chat messages, both checked against the lower quartile to signify disengagement. Additionally, we adjust this score based on the employee's pulse engagement score, incorporating overload if they are logging extensive overtime. Our next step is to create a forward-looking target for the next 3 months. This involves shifting the calculated quiet quitting flag, helping us anticipate potential dips in performance before they manifest. We ensure that our dataset remains practical by filtering out any fields that are not directly observable and could introduce unnecessary complexity. As we refine our dataset, we reorder the columns to enhance logical flow, focusing on variables that are more actionable and relevant for our analysis. Notably, we introduce a realistic exposure variable representing a standard rate over time. After restructuring our data, we conclude this cell by preparing to save the final dataset, which will serve as a foundation for subsequent analyses. In the next cell, we will likely dig deeper into specific patterns and correlations within this refined dataset, allowing us to better understand and address quiet quitting in the workplace. Cell 5. In this cell, we're taking a pivotal step in analyzing employee engagement by focusing on the concept of quiet quitting. After establishing our key flags, specifically the quiet quitting flag and the quiet quitting next 3M, we now shift our attention to detecting patterns that can provide deeper insights into this phenomenon. The first task here is to create trend and drift features for each employee. This involves examining changes in their behavior over time to understand if these shifts could indicate a pullback in engagement. We want to assess how much their performance or interaction varies from their previous benchmarks. This is crucial, as understanding these fluctuations can help us identify potential risks of employees engaging in quiet quitting behaviors before they fully manifest. As we move through the implementation, we have two potential paths. On one hand, we could create a straightforward, rule-based system that flags employees based on clear criteria derived from those trend features. This approach would prioritize interpretability, making it easier for stakeholders to understand why a particular individual is flagged. On the other hand, we could leverage machine learning techniques to develop a predictive model that would forecast quiet quitting behaviors in the upcoming 3 months. This would require a comprehensive dataset and careful consideration of the model's inputs to ensure its effectiveness. It's also essential to be mindful of assumptions we're making here. For instance, we need to consider how reliable our data is and whether there are external factors influencing these trends that we haven't accounted for. Additionally, interpretations of these features can vary, so clarity in defining what constitutes a significant drift in behavior is fundamental to avoid misclassifications. Looking ahead, the next cell will likely elaborate on our choice between these two approaches, providing insights into how we can effectively implement and evaluate either the rule-based flagging or the predictive modeling strategy. This will take our analysis further and help us better understand the quiet quitting dynamics within our organization. Cell 6. In this cell, we're introducing a method to build signals that may indicate a phenomenon known as quiet quitting. This approach is important because it enables organizations to proactively identify potential issues with employee engagement and productivity, allowing for timely interventions. First, we begin by copying and organizing our dataset, prioritizing the correct sequence by sorting it based on employee IDs and months. This sorting is crucial, as it ensures that our analysis is built on a temporal basis, looking at how a given employee's metrics change over time. The core of our logic involves creating new features that capture both rolling averages and changes in various engagement metrics. By doing this, we can better understand trends rather than relying solely on raw data, which may not reflect deeper shifts in behavior. Next, we calculate 3-month rolling averages for several important indicators, such as engagement scores and the number of tasks closed. This not only helps smooth out variability in the data, but also allows us to create baselines that are specific to each employee's performance trends. We also look at 1-month and 3-month differences for key metrics. This highlights any significant upward or downward shifts that might suggest a growing disengagement or lack of productivity. To address fairness across different roles, we introduce normalization for specific metrics, allowing us to compare an employee's current performance against their historical averages. This is essential for ensuring that variation due to role differences doesn't skew our interpretation of engagement signals. Finally, we synthesize these metrics into a single index, the Quiet Quit Signal Index. This composite measure quantifies the risk of quiet quitting based on changes in engagement, response times, output, and collaboration. It's designed to be interpretable, where a higher score indicates more concerning behavior. The next steps will likely involve analyzing these signals further, perhaps visualizing trends over time or correlating them with other performance outcomes. This exploration will help us better understand the underlying factors contributing to disengagement. Cell 7. In this cell, we're crafting a crucial metric known as the Quiet Quit Signal Index, designed to provide a swift evaluation of an individual's shifting engagement at work. This is particularly important as quiet quitting has widespread implications for team dynamics and productivity. By synthesizing trends over the past 3 months, we aim to distill various behavioral signals into a single score that reflects an employee's potential disengagement. The logic behind this score is built upon several key variables that we examine closely. First, we look at changes in engagement levels, where a decline indicates a potential issue. Simultaneously, we assess response latency. If it's increasing, it suggests individuals are taking longer to engage with tasks, a worrying sign of disengagement. Additionally, we analyze the volume of completed tasks and any rise in backlog items. A decline in tasks completed and more items piling up can further highlight problems in productivity and motivation. We also consider collaboration patterns, specifically through the frequency of chat messages. A decrease in communication can signal isolation or lack of teamwork, both indicative of quiet quitting tendencies. Whenever we see a higher quiet quit signal index, it raises red flags. Conversely, a lower index indicates that things may be improving, reflecting a healthier work environment. It's important to remember that while this metric is insightful, it's not infallible. There are always contextual factors to consider that might influence these numbers. For example, seasonal workload changes or external stressors could inadvertently skew results, so one should interpret these signals with caution. As we transition into the next cell, we will likely explore how to visualize these findings, making it easier for teams to grasp the implications of the index and take proactive measures to foster engagement and collaboration. Cell 8. In this cell, we're setting up a rule-based system to flag potential early warning signs of employee disengagement, which is vital for organizations aiming to maintain a healthy workplace culture. By analyzing specific engagement metrics, we can effectively identify individuals who may be at risk of reducing their effort at work, allowing for timely interventions. To start, we create a new column in our data frame called Flag Rule-Based, where we're combining 3 key engagement indicators. First, employees whose pulse engagement scores are 8 points or lower are identified, signaling a drop in their engagement levels. Next, we look at the number of tasks closed. Those with a decline of 6 or more are flagged as experiencing decreased output. Lastly, we also consider response latency, marking employees whose average response time is 10 minutes or longer, indicating they may be less responsive than their peers. Each of these conditions must be met for an employee to receive a flag, and the results are converted into integer format for clarity. After that, we calculate the mean of these flags to get an overall sense of how many employees are showing signs of disengagement. This provides a quantitative metric that can help us gauge the extent of the issue across the organization. Next, we focus on the most current month in our dataset, isolating employees who might be exhibiting the highest signals of disengagement. We sort these individuals according to their quiet quit signal index and select the top 25 to analyze in greater detail. The selected columns give us insights into their employee IDs, departments, levels, regions, remote work status, and the various metrics we have been tracking, including our newly created flag. This approach helps in pinpointing not just who is at risk, but also provides context with regards to their roles within the company. As we move into the next cell, we'll build on this analysis to delve deeper into the implications of these findings, exploring potential strategies to address the issues we've identified. This will foster a more proactive approach to employee engagement and retention. Cell 9. In this cell, we're looking at a data frame that provides a monthly overview of employee engagement signals, along with some crucial metrics that help us assess their well-being over time. Analyzing this data is essential for identifying potential issues before they escalate, particularly in relation to employee retention and productivity. The data frame contains key information for each employee broken down by month. It highlights current engagement and work signals, which tell us how engaged an employee is at the moment. In addition, we see rolling baselines that allow us to gauge how these signals compare to previous data, giving us insights into trends. Recent deltas inform us about the changes in engagement over time. In simpler terms, are employees getting better or worse in their work satisfaction? Another interesting aspect of this data frame is the inclusion of risk labels, or flags, that categorize employees into different risk levels. This could point to early signs of quiet quitting, a term describing when employees disengage from their work without formally resigning. By answering questions like how an employee is doing right now, whether they are improving, and the likelihood of quiet quitting, we can take proactive measures to maintain a positive work environment. Overall, this analysis is a vital step in creating strategies that support employees and enhance overall workplace morale. As we move to the next cell, we'll likely delve deeper into interpreting these signals or exploring ways to visualize this data, enabling us to communicate our findings more effectively. Cell 10. This cell focuses on enhancing our data frame by adding various features that provide deeper insights into employee behavior over time. By applying calculations such as rolling averages, differences, and percentage comparisons, we can develop a more nuanced understanding of engagement and performance, which is essential for driving organizational improvement. First, the cell establishes a grouped view based on employee IDs, allowing for personalized analysis. The first major step involves calculating rolling averages for specific metrics, like engagement scores and response times over the last 3 time periods. This provides a smoother trend that helps in recognizing patterns in employee activity and productivity. Next, the code computes the differences of key metrics over 1 and 3 time intervals for selected features. This step is crucial for detecting changes in behavior, such as sudden drops in task completion or fluctuations in responsiveness, which could signal broader engagement issues. The percentage of average calculations provide additional context. By comparing an employee's performance to their own historical averages, we can gauge individual variability and identify those who may be struggling or excelling. Finally, the creation of the Quiet Quit Signal Index combines several of these metrics into a single score, weighted according to their perceived impact on engagement. This index serves as a predictive tool, helping us to identify which employees might need additional support or intervention. Having made these impactful feature additions, the cell then returns the modified data frame for further analysis. This groundwork sets us up beautifully for upcoming cells, where we are likely to apply machine learning techniques to assess the relationships between these newly created features and various employee outcomes, driving actionable insights for management. Cell 11. In this cell, we're focusing on building a predictive model to assess the risk of employees engaging in quiet quitting over the next 3 months, utilizing a variety of features to do so. This is a crucial task for organizations aiming to understand employee engagement and retention better. The code begins by identifying the target variable, which represents whether an employee is likely to continue or reduce their effort at work, and it sets the scene for a more nuanced analysis. Next, we specify the features that contribute to the model. The numerical features encompass various metrics such as tenure, remote work ratio, and engagement scores, while categorical features consist of attributes like department and level. This combination is vital. It ensures we're capturing a comprehensive view of the employee's work context. Right at the start, we also deal with any early data inconsistencies by removing rows containing NaN values in critical features. This ensures our model is trained on reliable data. Then, we split the dataset using group shuffle split, which is particularly useful in this scenario because it maintains the integrity of employee-level data throughout the training and testing process. This helps avoid data leakage that can arise when the same employee appears in both the training and testing datasets. The heart of our modeling workflow lies in the integration of pre-processing and logistic regression through a pipeline. The pre-processing steps involve transforming our categorical features into a format suitable for the logistic regression model, ensuring that the model can accurately learn from our data. Once the data is prepared, we fit the logistic regression model to the training subset and then use it to predict probabilities on the test set. The model's performance is evaluated using two important metrics, ROC-AUC and PR-AUC. These metrics reveal how well our model discriminates between employees at risk of quiet quitting and those who are not. The threshold indicators provided give us a clearer understanding of what these scores mean, helping to interpret the findings effectively. In real-world applications, a PR-AUC around 0.69 signifies a strong predictive capability, especially when our baseline risk is relatively low. Lastly, we apply the risk scores back to the original dataset. This allows us to identify exactly which employees could be at risk in the upcoming months, enabling targeted interventions. Looking ahead, the next cell will likely delve deeper into the implications of these risk scores by possibly exploring how to act on this information to enhance employee engagement and reduce turnover rates. Cell 12. In this cell, we're generating a ranked list of employees based on their predicted risk of quiet quitting over the next 3 months. This particular analysis focuses on the latest month available in our dataset, which helps us ensure we're working with the most current information for our risk assessments. First, the code identifies the most recent month from the data frame, allowing us to hone in on just those records relevant to our current analysis. Following that, it filters the data to select only the entries corresponding to that latest month. This sets the stage for a more accurate understanding of employee engagement during this specific time frame. Once we have our subset of data, we sort these records by an important metric, the risk score for potential quiet quitting over the next 3 months. This score is critical, as it represents a probability estimate, though it's essential to remember that it doesn't provide guarantees, just likelihoods. By sorting in descending order, we prioritize employees who are most at risk, which in turn allows us to focus our intervention efforts on those who may need it the most. The output includes a variety of information, such as employee IDs, department affiliations, and engagement scores, allowing us to easily identify key characteristics of the highest risk individuals. This granular data helps organizations make informed decisions about potential retention strategies. However, it's crucial to approach these results with caution. The risk scores are based on modeled probabilities that incorporate a range of factors, including historical performance and engagement indices. But they should not be the sole basis for decisions. As we move forward to the next cell, we will likely delve deeper into how to interpret these risk scores, or explore tailored strategies to address the needs of employees identified in this list. This will give us a more comprehensive toolkit for fostering a supportive work environment. Cell 13. In this code cell, we're focusing on identifying specific reasons why employees may have been flagged based on their engagement and performance metrics. This process is crucial for managers and HR professionals to address potential issues before they escalate, thereby fostering a healthier workplace environment. The function defined here is called reason codes, which takes a single row of data as input. It systematically evaluates various performance metrics over a 3-month period. For example, if an employee's engagement score has dropped significantly, it's noted as a potential red flag. Likewise, if they have closed fewer tasks or their response time has increased, those factors contribute to the list of concerns. The key variables here include pulse engagement scores, the number of tasks closed, response latency, backlog items, and chat messages exchanged. each offering insights into different aspects of employee activity. After defining this function, the code then applies it to a filtered data frame, which contains only the most recent month's data. By creating a new column labeled Reason Codes, it catalogs all the reasons for concern for each employee. This allows us to pinpoint who may need additional support or intervention. To wrap it up, we sort this updated data frame by a metric called the Quiet Quit Signal Index to highlight the employees who are exhibiting signs of disengagement. Displaying just the top 15 employees, we focus on key identifiers like employee ID, their department, level, and the identified reason codes for why they were flagged. Moving forward, the next cell will likely explore these flagged employees in greater detail, potentially considering how to address the underlying issues and improve overall engagement. This ongoing analysis can lead to actionable strategies that enhance employee satisfaction and productivity. Cell 14. In this cell, we dive into an important metric known as the Quiet Quit Signal Index. Understanding this index is essential because it provides insights into employee engagement trends within an organization, helping leaders identify which individuals may be disengaging or quiet quitting. Essentially, we're aiming to quantify how concerning these trends are relative to the entire population being assessed. The central idea is that a higher score on this index signals a more troubling trend. This allows organizations to take proactive measures before it develops into a larger issue. In practice, we're going to derive a top-N list from these scores, which will serve as our actionable output. By focusing on a carefully considered selection based on their scores, we can prioritize who needs attention. To better manage these trends, it's useful to define thresholds based on percentiles. For example, individuals in the top 1% might represent an urgent review situation, indicating immediate intervention is necessary. Those in the top 5% could prompt a check-in from a manager to gauge the situation, while the top 10% might just need ongoing monitoring to ensure issues don't escalate further. As we engage with this metric, it's important to keep in mind the assumptions behind our threshold decisions, as well as the potential pitfalls of overlooking or misinterpreting scores. This understanding is crucial to ensure that the responses to these indices are not only timely, but also effective. Looking ahead to the next cell, we'll likely explore how to leverage this data for targeted interventions, potentially creating frameworks that managers can use to address the concerns raised by the index. This will help in crafting a more engaged and motivated workforce. Cell 15. In this cell, we're delving into the distribution of the Quiet Quit Signal Index to better understand how risk is distributed across the organization for a specific month. This analysis holds significance because it allows us to visualize potential employee engagement levels and identify trends that might need our attention. To start off, we're importing essential libraries like Pandas and Plotly, which are key for data manipulation and visualization. We then convert the month column in our data frame to a date-time format. This step ensures that we're working with dates correctly, which is crucial for accurate filtering later on. After preparing the data, we focus on the most recent month's data by grabbing the maximum date available. This gives us a clearer and more relevant snapshot of current conditions. Next, we create a new data frame, including only the data for this selected month. This targeted approach allows us to concentrate on the current context, making our findings more actionable. Then, we employ Plotly Express to visualize this information through a histogram. The x-axis represents the Quiet Quit Signal Index, spread over 60 bins to capture its distribution effectively, while the title dynamically reflects the month we're analyzing. Additionally, we add a marginal box plot to provide another layer of insight into the distribution's main statistical features. As you can appreciate, this visualization helps us identify how widespread the quiet quitting phenomenon might be within the organization. However, it's essential to remember that correlation does not imply causation. There could be factors influencing these figures that we haven't accounted for yet. In terms of what to look out for, examining the shape of the histogram can reveal whether most employees lean toward high or low engagement levels. In moving forward to the next cell, you can expect it to build upon this analysis by potentially incorporating comparisons over time or adding context to strive for a deeper understanding of employee sentiments. Cell 16. In this cell, we're diving into the concept of risk concentration by generating a heat map that visualizes how the average quiet quit signal varies across different departments over time. This analysis is crucial as it helps us identify which departments may be experiencing higher levels of disengagement, allowing for targeted interventions. To achieve this, we first aggregate the data by month and department. In this aggregation, we compute three key metrics: the average quiet quit signal index, the 95th percentile of the quiet quit signal index, and the average rate of quiet quitting expected in the next 3 months. Each of these measures gives us insight into the general sentiment and impending trends within the company. Next, we pivot the aggregated data to transform it into a format suitable for visualization. By setting the department as the index and the months as columns, we create a matrix that facilitates a clearer comparison of the average quiet quit signals across time and departments. This pivoting is an essential step because it lays the groundwork for our final visualization. Utilizing Plotly Express, we create an ImShow heat map that visually represents this data. The heat map is configured to adjust its aspect ratio automatically, ensuring that it displays neatly. The title clearly indicates what the viewer is looking at, emphasizing the focus on average signals by department. As we render this visual, we can make several assumptions, such as the completeness and accuracy of the underlying data, which can impact the overall insights. It's also vital to consider that while higher signals may indicate disengagement, further exploration is necessary to understand the underlying causes. Looking ahead to the next cell, we can expect a more in-depth analysis of the factors driving these quiet quit signals, perhaps exploring correlations or trends that emerge from this initial heat map. This will help us uncover not just where the risk lies, but also why certain departments may be struggling more than others. Cell 17. In this cell, we're generating a bar chart that visualizes the top 20 employees exhibiting signs of quiet quitting for the most recent month available in our dataset. This visualization is crucial because it highlights individuals who may be disengaged or underperforming, allowing us to investigate the underlying reasons and address potential issues proactively. We start by identifying the most recent month in our data, which sets the context for our analysis. After filtering for this particular month, we create a new data frame that will specifically hold the relevant data for our visualization. The next step involves sorting this filtered data frame by the quiet quit signal index, which quantifies the signs of disengagement. We're focusing on the top 20 entries as these are likely to have the most significant impact on the overall team dynamics and performance. With our filtered and sorted data in place, we proceed to create the bar chart using Plotly Express. The horizontal bars will represent the quiet quit signal index on the x-axis, while the y-axis will feature the employee IDs. Importantly, we're adding a color dimension based on departmental affiliation, which helps to visualize where potential clusters of disengagement may reside. We've also included multiple hover data points, such as the employee's engagement score and average response latency, providing deeper insights into each individual's performance. As a learner, it's essential to keep in mind that data quality plays a critical role in this analysis. If our initial dataset contains inconsistencies or inaccuracies, it could skew our findings. Looking ahead, the next cell will likely build on this visualization by addressing how to interpret the results and perhaps suggest interventions for those identified in the chart. By the end of our analysis, we'll be equipped to foster better engagement and improve team dynamics. Cell 18. In this final cell, we wrap up our exploration with a concluding statement that signifies the end of our analysis. While it might seem straightforward, it holds significance as it allows us to summarize the insights we've gained throughout the notebook. Typically, a concluding cell can serve multiple purposes. It provides closure by reiterating the main findings and emphasizes the importance of the work we've done so far. In a more intricate project, you might highlight key metrics or highlight areas for further exploration. But here, we succinctly acknowledge the journey we've taken and its implications. As we reflect on the work, it's essential to consider what we've learned and how these insights can be applied in practical situations. The analysis we conducted earlier serves as a foundation, and this conclusion serves as the bridge to our future inquiries. Moving forward from this point, the next steps could involve taking our findings and integrating them into real-world applications, or exploring further intricacies within the dataset. It's all about building on the knowledge we've established, paving the way for deeper understanding and exploration. This transition into practical application is where our learning can truly take shape and impact decision-making processes.